Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab, and in the search question, search happy number and hit enter. And we have the question number 202, and it's come under the easy category, but like generally it's been asked in the interview. So you can say it's an interview question. So click on it. Okay, so write an algorithm to determine if a number n is happy. So we have given some number n. So if you see the function is happy function, so we have given some number n, which is an integer. We need to just determine whether the number is happy or not. And what does that mean by happy? Right. So how to calculate that happy number is not. So there are some processes given. So starting with any positive integer, replace the number by the sum of the square of its digit. Repeat the process until the number equal to 1, or it loops endlessly in a cycle which doesn't include 1. So as an example, so let's suppose we have given number 19, n is equal to 9. So we have to calculate whether the n is happy or not happy. So if it is happy, we have to return true. If it is not happy, then we have to return false. Okay, but how to calculate whether the n is 19 is happy or not? So what we have to do is, so let's go to the whiteboard. So let's look at the first example. We have the number 19 is given. So what we will do, we will take the first digit. First digit is 1 and the second digit is 9. So what we will do, 1 square plus 9 square. Like we will do square of each and every digit of the particular number. So what we get, 82. And we have to repeat this process until we will not get the 1, or until we will not get the loop. Right. So 82 is equal to 1? No. Then again what we will do, we will like now in 82, let's separate the digits. So one digit is 8 and one digit is 2. So 8 square plus 2 square, 68. So is 68 is equal to 1? No. Now calculate 6 square plus 8 square, 36 plus 64, 100. Okay, now 100 has three digit, 1 0 0. So 1 square plus 0 square plus 0 0 square. Is sum is equal to 1? Yes. So once we reach the sum is equal to 1, then we will say that okay, it is the happy number. So example, like 1 square plus 9 square is equal to 82, 8 square plus 2 square is equal to 68, 6 square plus 8 square is equal to 100, 1 square plus 0 square plus 0 square is equal to 1. So we reached the 1. So now we will say okay, 19 is a happy number, and we are going to return true. But let's suppose see the other example, 2. So we have number given 2. So we will repeat the same process. If number is given, we will separate each digit. So there is only one digit, we will scale it, 2 square. Now we'll get 4. So it is not equal to 1. Then we will do again square. Now 16. Now we will do again square, but square of digits. So 1 square plus 6 square, 6 are 36, 1 is 36 plus 1, 37. Now what we will do, again square. 7 7 is 49, 3 3 is 9, 49 plus 9, 58. Now we will do 58, like 5 square plus 8 square, 25 plus 64, 89. Now 89 ka square, not 89 ka square, but 8 square plus 9 square. So 64 plus 81, 145. Now 1 square plus 4 square plus 5 square, 42. 4 square plus 2 square, 4 4 is 16 plus 4, 20. Now 2 square plus 0, 4. So we will get the 4 again. Now it is the endless loop. So it will become the endless loop, and we are not reaching 1 because the 4 is repeated again. So it is an endless loop. So in this case, we will return false. So how to do that question? So let's write some steps. What we have to do. Okay, so we have to return either true or either false. Right? So in the return statement, it should be either true or either return false. Right? Okay. So once we have given some number, so first what we have to do, we have to separate its digits. Only then we are able to do the square, because okay, 1 square plus 9 square, then we are getting to 82. But how to separate the digits? So either you do like a modulus, or you can say remainder and the quotient, or in the Python we have the dim mode function. So in the dim mode function, we will give the number and we will give the 10. So what it will do, it will return the quotient and the remainder. It will give you the quotient and the remainder. All right. So let's suppose number 19. So if we divide, so 19 by 10, so 10 banja 10 and remainder is 9. So what it will return, it will return 1 comma 9. So d mod 19 comma 10. So basically we have separated the digits, so we get the 1, we get the 9. All right. So but if the number is 3 digits, let's suppose the number is 100. Now so 10 10 ja 100, so number is 10 and remainder is 0. So only in this case only one digit has been separate. So again we have to repeat the same process on the 10. So again we have to repeat the same process on the 10. Demode 10 comma 10. So 10 1 ja 10 and remainder 0. Then we get the second digit. Second digit is also 0. Basically the remainder, we are getting the remainder. Then we will get the again the same process. So same process means like div mode and 10 comma 1. So we will get the quotient 0 and the remainder 1. So we have to repeat how we are going to separate the digit until the number becomes 0, until the quotient becomes 0. So by this way we can get the all the digits. So digits in the form of a remainder. So 0 0 1. All right. So we have to do that. Once we get the digit, so let's suppose we get the digit, we will scale it. So we will digit scare, and then we are going to add the another digit of scare. All right, digit starts as scare, and we are calculate the sum. So let's suppose it's sum. Then we are going to check if the sum is equal to 1 or not. So if sum equal to 1, if it is equal to 1, then we are going to return true. All right, if it is not equal to 1, right, let's suppose 1 square plus 9 square 82. So we will check whether the 82 is equal to 1. No. Then what we have to do, we are going to again separate the digit. Basically we are again going to do the this process again. So but better we will put this in some function. So again we will do the same process again, but before doing the same process again, we will check whether the 82 is already repeated or not. Because if we do 2 square plus 0 square 4, and we started again 4 square plus 16, then again 37, then again 52, then it will like endless loop. So before doing any scare, before doing any scare, what we will do, we will check whether this number already like exists or not. So how you are going to check whether the number already present or not? So basically we have to take some extra space of some unique element. Either you can take dictionary or you can take the set. So in either in the dictionary or in the either in the form of set. So we are going to store the number. So before doing the scare, we will check if number in set. If number already in set, then we are going to return false. Otherwise, we are calling the same process again, right? Same process again, but on which number? On the sum. All right. Call same process again on sum. On sum means like this 82. All right. So now let's try to implement this thing. So first we have to do, we have to separate the digit and we have to calculate the sum. So this process we have to do. So before for this process, let's create some function. So basically what we have to do, like sum of digit scare. All right. And it is going to return some output. Some output. Let's suppose it will return some output. So let's create that function. Def sum of digit scare self and if we are calling it self, then we have to call this like self dot. Okay. So what we have to do, so first we have to like whatever the n, because like here in starting, let's suppose if someone is passing 19, so 19 will go here, then it is going to call this function. Then first function is we have to separate the digit. How you are going to separate the digits? Using the demode functions. So what it will give you, quotient and remainder, we are calling the dim mode on 9 and 10. All right. So we will get a dim mode. It's not a D, yeah, so it's a dim mode function. then it is going to give us the quotient and it is going to get the remainder. So we'll get the remainder. Remainder means basically one digit. So we will get the 9. Then, and we have the like one separate and in the question. But if there is the 3 digit or there are 4 digit, because it could be 2 to power 31 minus 1, like the constant is n to power 2 to the 31 minus 1. So we don't know whether the quotient is of 1 digit, 2 digit, 3 digit, or 4 digit. So basically we have to repeat this process again. So for the quotient, we will get the again the same thing. So you can say sum of digits is equal to sum of digits plus remainder remainder square, right? Or you can say remainder is a digit. So we will get the digit. But what is some digits? So initially we will take it as a 0, right? Now we will get the quotient. So quotient means like we will have to follow this process again until our quotient is not equal to 0. Until our quotient is not equal to 0. So we have to do this process again, because only and only then we will get the sum of all the digits while n not equal to 0. All right. While n not equal to 0, we have to do the same process again and again. Then we will get the sum of digit. And in the question we can say n, because here we are passing n. So it will give some remaining number and it will give the digit. It will give the one digit. Is, let's suppose in case of 100, it will give us the remainder, that is the digit, and it is giving me the remaining number, that is the n. And we are going to call this, and we are like adding in the some digit. Uh, then we are going to return some digits. Correct. So here we will get the some digits. Then if we will check if, or you can say digit sum, something like the digit sum, because a variable. Then we will check if n equal to 1. If n equal to 1, what we will do? Return true. All right. Then return true. But let's suppose first we are passing 19. We pass 19 here, 19 here. Then it will go here. Then it will do all the calculation for all the 19 number. So we will get 82. All right, 1 square plus 9 square, we will get 82. So it is going to return 82. All right, so we will check whether the n is equal to 1. So 82 is equal to 1. No, it is not. 82 is not equal to 1. Then we have to repeat the same process again. So we have to repeat the same process again. So we have to repeat the same process again. So we have to run some loop, while loop. So while, 1 minute, let me put this inside. Yeah, fine. So we have to do the same process again. But if you see this question, like in the scenario number 2, before doing any scare, what we have to do, we have to check whether the number already exists or not. Only and only then we will repeat the same process again. So we will check whether the 82 already exists or not. But we have to store somewhere. So we will take some visited array, not array, either set or either dictionary. So we will check while n not invested. All right. So while n not invested, so first number is 19. So 19 is not in the visited because 19 is empty. Then we will mark it as a visited. Visited dot add n. Then we mark as a visited, and then we will perform some calculation. All right. Then we will perform some calculation and it is going to return 82. Then we will check if n is equal to 1. No, 82 is not equal to 1. Then we are going to again check whether 82 is in the visited set. No, in the 82 it's only 19, the first number. Then we are going to add 82. Then we are again going to calculate. So while n not invested, so in this case for well, like 2, 4, 16, 37, 58 till 20, then we will once we get the 20. All right, so we will check whether the 20 is not in the visited. No, so we will do the calculation again for. So we will do the calculation again, and we will like get the 16 or 4. Then we are going to check whether the particular number is in the listed. Then we will say yes, because 4 is already there, because we already store 4, or you can say 16. If you are adding first, then you are checking 16. If you are adding at last, then you are checking 4. Like, but whatever you, like, at what stage you like add the number into the listed array, that doesn't matter. So we will check whether that particular number is in the listed. So yes, that number is in the listed. Then we will run, like, the while loop will become break, and we are uh, come out of the loop. And if we come out of the loop, then we are going to return false. So let's try to run this question. So let's try to run it. So our answer is wrong. Why it is wrong? So let's see why it is wrong. For first case is fine. For 19 is fine. Okay, for 2 is wrong. So something is wrong. So while n not invested and vested dot add n. Okay. It looks, maybe we need to add the later stage. One mistake what we did is we changed the variable name here, but we have not changed here. So 1 minute, we have not changed here. So maybe that is the mistake. So let's try to run it. Yeah, now our solution has been accepted. So that's it. So here we are like using some extra space, and we are like running some loop. So like, if you understand the logic, na, then writing the code is not a very big task. Like, what we have to do, if there is some number, then we have to separate the digit. How to separate the digit? Either we directly use the demode function, it is going to give the quotient and the remainder, or you can do within two steps. Like, one is modulus operator and one is the divide operator. So or either in the one step. So I am doing in the one stage only. So we are getting that. But it is going to, but if it is 3 digit, then our quotient could be of 2 digit, but we have to scare of each and every digit. So basically we have to run get the, how you are going to get the sum while in the, like, in the while loop, until unless we will not get the quotient as a 0, or you can say the number as a number is equal to 0. So it will going to some sum. So it is going to return some sum. Then we are going to check if the sum is equal to 1. Okay, if it is equal to 1, then we are going to return true. If the sum is equal to 1, then we are going to return true. Otherwise, like, we have to check whether the, like, otherwise we have to repeat the same process. Otherwise we have to repeat the same process. But before, because it might end into the endless loop, so that's why we have to check, like, whether the particular number is already there or not. So for that, how we are going to check? We will like take some extra memory set, and then before proceeding any further, like, we are going to mark as a visited. So we pick one number, mark as a visited, and then do the calculation. Then pick the second number, mark as a visited, and then do the calculation. All right. So that's the end of the video. So it's a like a good question. You can also try that. So thank you.